Today we want to talk about definite integrals and the properties that they have. So the first property that you have is if you integrate from a to b of a function with respect to x, that is equivalent to negative integral from b to a of f of x dx. So what this means is you can change the upper and lower limits, and that will only affect the sign of your final answer. The second property that we have is that if you are integrating with two values that are exactly the same, so your upper and lower limits are equal, then your integral is going to be 0. If you're not covering any area, you're starting at any point at the exact same point, we would expect the area to equal 0. Our third property is that if you have a constant that is multiplied by the function as part of the integrand, then you can take that constant outside of the integral and multiply it by the integral of the function itself. So similar to what we did with limits, where you could pull the constant out to the front and the limit just became that constant times the value of your limit of the function. Same thing works with integrals. The fourth property is that we can add and subtract integrals if there are functions being added or subtracted inside our integrand. So you can break up f of x plus g of x and make it be two integrals, one with f of x and one with g of x. Notice that the upper and lower limits stay the same for both, as well as your variable of integration. The other thing that we can do is we can add or subtract the intervals themselves. So if I have one integral that goes from a to b, and a second integral that goes from b to c, and I have the same function in my integrand, well then I can make that be one long integral from a to c of my function. So all of these are helpful as we try to manipulate and evaluate these different integrals. So if you need to pause the video to finish writing down all of these rules and the notes about them, feel free to do so. If you're ready to move on, we'll go ahead and talk about some examples on the next slide. So the first thing that we're told is that we have the integral of f of x with respect to x from 0 to 3 is equal to 6, and from 3 to 7 of f of x dx is equal to negative 8. And so we're going to use the different rules that we just saw on the last slide to help us learn what this value is going to be. So our first integral has a lower limit of 3 and an upper limit of 0 of f of x dx. And so you notice that this matches this first set of information that we're given, except that the upper and lower limits are reversed. And so if you look back at the first rule that we had on the last slide, we can reverse our upper and lower limits, and all that does is change the sign of our value. So the integral of negative 0 to 3 f of x dx, notice if I change my upper and lower limits, that now becomes negative. And so now that's going to be equal to negative 6. My 6 is coming from this value up here that I have. So the value for this integral is going to be negative 6. Okay. The next example that we have is an integral from 0 to 7 of our function. We don't know any information specifically from 0 to 7, but we do have from 0 to 3 and from 3 to 7. So if you look back at our rule number 5 on the previous slide, we can break apart our intervals and have them be added together. So this integral from 0 to 7 is the same as 0 to 3 f of x dx plus 3 to 7 f of x dx. And so this is equal to 6 plus negative 8, which is equal to negative 2. All right, our third example, we have our integral of f of x with respect to x from 3 to 3. Because our upper and lower limits are exactly the same, this is just equal to 0 because of the second rule that we had on the previous slide. So that one's easy enough. On the fourth one, we have an integral from 7 to 3 of 3 times f of x dx. And so we can swap our upper and lower limits, and remember when we do that, that makes our integrand negative. So the first thing we can do is make this be negative and then we can also take a constant and pull it outside of our integral. So we now have negative 3 integral from 3 to 7 f of x dx. And so now this is a value that we know from the information that we've been given. And so this will just be negative 3 times negative 8, which is equal to 24. For the next example, we have several things that are happening. We have for this next problem, I'm going to give you some additional information, and that is that the integral from 3 to 7 of 2 with respect to x is equal to 8. So we'll eventually find out how I arrived at this answer. But we're going to use this to help us find the value of this integral. And so we have two things that are being added together as well as a constant being multiplied by our function. So we can just break these apart using our different rules. So we have the integral from 3 to 7 of 2 with respect to x plus our integral from 3 to 7 of 3 f of x dx. And of course we can take this constant and pull it out to the front of our integral. And so now we can just substitute the different values that we know. And so like I mentioned, we're going to have this value equal to 8 plus 3 times this value we are told is negative 8. So we end up with 8 minus 24, which gives us negative 16. For this next integral, we need to use what we know about even functions. So if you'll remember, even functions are functions that are symmetrical across the y-axis. So for example, a parabola is symmetrical across the y-axis. And so because of that, if you're going from the same point on either side of your y-axis, with one being negative and one being positive, these two areas on either side of your y-axis are going to have the same value. So if f of x is an even function, your integral will be equivalent to 2 times the integral from 0 to your endpoint of your function. So in this case, it's equivalent to 2 times 6, or 12. If we have an odd function, then excuse me, your function is symmetrical across the origin. So, for example, you may have a line that goes through the origin, and if that happens, then you can tell that your two areas are going to end up canceling each other out. You might have triangles of similar size and dimensions, so their areas will equal 0 since one of them is below the x-axis and one is above the x-axis. So, for an odd function, if these are limits that are the same except for the signs, this will equal 0 because it's an odd function and it's going to cancel out.